So finally, we want to talk about the graphs of logarithms. Now that we understand them a little bit, we understand what their bases are, what they mean, and how to work with them, and how to evaluate them. We want to know, what do their graphs look like? Well, the graph of y equals log base b of x has the following properties. And this is just the parent graph. No shifting, no nothing, just a very basic. As long as the base is what?
10.
Positive and not equal to
1.
1. The base has to be positive and not equal to 1. So b has to be positive, not equal to 1. It will always pass through the point 1, 0, which is interesting because the exponential y equals b to the x passes through the point 0, 1. The logarithmic graph will also pass through the point b, 1, whereas the exponential graph passes through 1, b. The y-axis is still an asymptote. That's different. What's an asymptote for the exponential? X-axis. So what type of asymptote is this? The y-axis is a vertical. Yeah. So these have a vertical asymptote.
Will they ever be shifted vertically?
Not vertically, no. Because if you shift a vertical asymptote vertically, it's still in the same spot. And then finally, the domain is everything from 0 to infinity, but the range is all real numbers. So they're exactly opposite, which basically means that y equals log base b of x and y equals b to the x, they are inverses. And knowing that can help you graph them without a whole lot of trouble. They are inverses. That's kind of the thing you need to know. If you don't know how to graph a logarithm, graph its inverse with the same base, and then just switch the x's and y's. So that's a really easy way to graph a logarithm, especially because our calculator doesn't easily handle anything except base 10 and base e. So since your calculator doesn't handle that very well, you can do it by hand very easily by graphing the exponential and then switching the x's and y's. Take a look at this slide. On the left, we have graphed y equals b to the x for any base that is greater than 1. And over here, this is log base b of x. Notice how they have symmetry about the line y equals x. If we fold them, they should match up perfectly because they are inverses. And inverses switch the x's for the y's and the y's for the x's. Over here, this is an example of exponential decay. Y equals b to the x for a b less than 1 but still positive. And over here we have the graph of a logarithm whose base is between 0 and 1. Notice they also fold along the line y equals x because they are inverses of each other. Pause for a second, let you take that in. Because logarithms are so much more difficult to graph than exponentials, let's just kind of get some notes on how to do that. First off, find the inverse. And the good thing is to find the inverse, you don't even have to really work it out. Because it's a logarithm, the inverse is just y equals 2 to the x. So as long as it's a very basic with no shifts, no reflections, find the inverse. The inverse is just the exponential with the same base. As long as there are no reflections or translations or any kind of shifting, as long as it's just kind of a parent function, there's the inverse. Then make a table for the inverse. We're going to make a table for y equals 2 to the x. That should go really, really quickly. You should kind of know these by now. What am I going to start with? 0, 1, 2, 3, and -1, -2, and -3. You should be able to do all of this without a calculator. What's 2 to the 0 power? 1. What's 2 to the 1 power?
2.
What's 2 to the 2?
4.
And 2 to the 3?
8. 1/2.
So you make your table for the inverse. Got it?
Yeah.
But that is not what you graph. What does an inverse do? It switches the x's for the y's and the y's for the x's. So now you make a new table by switching the x's and the y's. Just invert the points. 1, 0, 2, 1, 4, 2, 8, 3, 1/2, -1, 1/4, -2, and 1/8, -3. And that is what you graph. Those are the ordered pairs for f of x equals log base 2 of x. So it's much, much easier to make the table for the inverse, for the exponential, because your brain is going to see that a whole lot faster and you know how to do that. Then to graph the log with the same base, you simply switch the x's for the y's and the y's for the x's. So let's take a look. 1, 0, 2, 1, 4, 2, and then 8, 3, 1/2, -1, 1/4, -2, and 1/8, -3. So if we look at those ordered pairs and those points, we can see that it is hugging which axis?
Wow.
It is acting as a vertical asymptote right here, the y-axis. And that's all you have to do to graph logarithms. So one more time from the top. First, consider the exponential with the matching base. And we do that because they are inverses of each other. Then we just make a quick table for the inverse. So this is the inverse table. Those are not the points we use. We switch the x's and the y's, and these are the log points. Those are the ones we put on our graph. Any questions about that? We're all good. We understand it?
Absolutely.
That wraps up section 4.3.